Okay, section 2.5 on rational functions. So since I'm not there, I'm going to go kind of slow through the notes. If you need to pause the video, please do. There are 2 examples at the end that I walk through all the steps that we're going to be talking about in this section. So we're looking at rational functions, which can be written in the form of a function over a function or a numerator over a denominator, where both of those are polynomials and cannot equal to 0. The domain of a rational function is whatever will make the denominator undefined. So if I have the function f of x equals 2x plus 3 over x minus 4, this is an example of a rational function because it looks like a fraction. The domain is whatever will make the denominator undefined. So in this case, if I set x minus 4 equal to 0, x will equal 4, and that's what will make the denominator undefined. So the domain would be all reals except equals 4. Okay, I'm going to the next slide now. If you need more time, just hit pause. So first we're going to look at vertical asymptotes. So vertical asymptotes are at the zeros of the denominator. If I have the function f of x equals x squared plus x minus 2 over x squared minus x minus 6, then I'm going to set the denominator equal to 0 and solve. That's going to tell me where the vertical asymptotes will be. So you can factor the top and bottom of the polynomial. The top factors into x plus 2 times x minus 1, and the bottom is x plus 2 times x minus 3. You always want to factor just in case something will cancel out. So you notice that the x plus 2's cancel out here. So then I would set the denominator equal to 0, and that's where my vertical asymptote will be, at x equal 3. Okay, I'm going to the next slide. If you need to pause, pause. Next will be horizontal asymptotes. So there are 3 different rules for horizontal asymptotes. The first one is if the highest exponent on top is less than the highest exponent on bottom, the horizontal asymptote is y equals 0. So an example might look like this, x plus 1 over x squared minus 4. The highest exponent on top is 1. The highest exponent on bottom is 2. So since the top is less than the bottom, the horizontal asymptote is automatically y equals 0. The next option is if the highest exponent on top is equal to the highest exponent on bottom, then the horizontal asymptote is y equals the leading coefficient on top divided by the leading coefficient on bottom. So an example might be 2x squared plus 1 over x squared minus 4. So both of these are x squared. So we take the leading coefficient on top is 2 divided by the leading coefficient on bottom is 1. So 2 divided by 1 is 2. So that would make our horizontal asymptote y equals 2 for this equation. Okay, and our third option is if the highest exponent on top is greater than the highest exponent on the bottom, there is no horizontal asymptote. So an example would be 2x squared plus 1 over x minus 4. So since the top is a higher exponent than the bottom, there is no horizontal asymptote. Okay, now I'm going to go on to the slant asymptote. If you need to pause, please do. So the slant asymptote is when the highest exponent on top is exactly 1 greater than the highest exponent on the bottom. So if I have x squared minus x over x plus 1, 2 is exactly 1 more than the exponent of 1 on the bottom. So when this is the case, we have a slant asymptote. To find out what the slant asymptote is, we're going to use long division to divide the polynomials. The resulting linear function is the slant asymptote. So here's another situation where we have to use long division instead of synthetic division to solve this problem. So I'm going to take the polynomial that I'm dividing by goes inside, or that I'm dividing goes inside, what I'm dividing by goes outside. I didn't show the work here. You can work this out yourself, but when I divide x squared minus x by x plus 1, I get the equation x minus 2. And I could keep going to find what the remainder is, but I only need those first two terms. First two terms gives me the equation of the slant asymptote, which is just y equals x minus 2. Okay, going to the next slide. So I'm going to do two examples with you. You need to give yourself plenty of space above this equation and below this equation. So my suggestion would be for the first time that we work through this, maybe give yourself about half a page, depending on how big you write. And in the middle of that half page of space, you need to write this equation on the left-hand side. So the rational function that I'm going to graph here is x squared minus 5x plus 4 over x squared minus 4. So we're going to take this half page of space and we're going to divide it into 4 equal pieces. So you can do a dashed line or a solid line, whatever helps you out. So every time that you graph a rational function, I expect to see something like this. I promise you it is much easier to graph them this way using this method than it would be to do anything else. All of the different asymptotes that we've already talked about, we're going to go over that when we graph these. In each quadrant of this section of paper, you're going to see all the aspects that we need to know in order to graph this rational function. Okay, we're going to start with the horizontal and or slant asymptotes. And to find those, we're going to compare the first two terms or the leading terms in the top and the bottom. Okay, since the leading terms in the top and bottom have the same exponent, this tells me that I have a horizontal asymptote. It wouldn't be a slant asymptote. Slant is when it's exactly one more than the bottom. And the rule is when the exponents on the top and bottom are exactly the same, then the horizontal asymptote is going to be the leading coefficient divided by the leading coefficient. So in this case, 1 divided by 1 is equal to 1. So our horizontal asymptote for this equation is y equals 1. Next, we're going to look at y-intercepts. Y-intercepts are when x is equal to 0. So I could plug in 0 for all the x's and simplify, but what works out is that if you take the constants on the top and the bottom and divide those terms, then this will give you your y-intercept. So the y-intercept will be positive 4 divided by negative 4, which is negative 1. So this point would be at 0, negative 1. Okay, on the other side of our paper, we are going to factor the top and factor the bottom. This is going to help us find the x-intercepts and then the vertical asymptotes. So if I factor the top and the bottom, for this polynomial, we're going to get x minus 4 times x minus 1 over x minus 2 times x plus 2. Okay, so the top of our factors are going to tell us about the x-intercept. So we're going to set those top two factors equal to 0 and solve. So for this equation, x will equal 4 and x equals 1 are the x-intercepts. The bottom two factors are for the vertical asymptotes. So you set those equal to 0 and solve as well. So our vertical asymptotes for this graph are 2 and negative 2. So now I'm going to graph, and I'm going to put all of this information up here in the corner just so that I can see it while I'm graphing. So the horizontal asymptote is at y equals 1, so I'm going to draw that as a dashed line. The vertical asymptotes are at 2 and negative 2. Then I'm going to plot my x and y intercepts, which will be points. So the y-intercept, negative 1, x-intercepts, 4, and 1. So you can see that these points really don't help me out a whole lot. Remember that the asymptotes are lines that it gets really close to and on occasions doesn't cross. So since we have 3 asymptotes going on here, there will be points on the graph that it will cross one of them but stay between another 2, and you'll see that when we plot these points. So you can type this into your calculator and then go to the table and plot a few more points. So I've picked a few points. I'm just going to put those up really quick. I wanted to pick some on the far left-hand side to figure out what was going on over here because I've kind of got a couple points in the middle and then one point on the right. So I need to figure out kind of in each section of the graph what's happening. So on the far left, here's a few points. So I can see that it's getting really close to that horizontal and vertical asymptote in the upper corner. And then I found a few more points in the middle here. So you can see that it is actually increasing between these two vertical asymptotes. And then a couple points on the far right as well. And you can see that it's increasing here as well, and it's bound in between the vertical asymptote and the horizontal asymptote. So then you can approximate the curve in between each of those. And it doesn't have to be perfect. You're just trying to approximate it using the information that we got earlier, finding the asymptotes and the intercepts, and then you can use your calculator to plot a few more points. So what I've also done is shown you the display on the calculator. If I was to type this one in the calculator, x squared minus 5x plus 4 divided by x squared minus 4. And notice that I put the top polynomial in parentheses and the bottom polynomial in parentheses. And if I was to graph this, here's the graph on my calculator. So this should look very similar to the graph that we did by hand. Now your calculator sometimes will have a line that looks like the vertical asymptotes, but your calculator is actually not graphing it correctly. It is connecting the top and bottom where it's going to positive infinity and negative infinity. It's connecting those with a line, and it's not supposed to. But we can pretend that those are the vertical asymptotes. Okay, so I'm going to do another example. So again, I'm going to write this polynomial in the middle of my paper so that I have space above and below. And I'm going to divide my paper into 4 equal pieces in 4 quadrants. Okay, so first we're going to talk about the horizontal and slant asymptotes. So you're going to compare the leading coefficients and the highest exponents for the top and the bottom. So for these polynomials, the top is higher than the bottom, so that means that there will not be a horizontal asymptote, it will be a slant asymptote. So in order to figure out what that slant asymptote is, we're actually going to do long division and divide the top polynomial by the bottom polynomial. And notice I put all those missing terms in there with 0 x's. So we're going to take this step at a time. Remember, when doing long division, you're comparing first term into first term. So I need to know what times x squared will equal 2x to the third. Well, that's going to be 2x. So then I multiply 2x times all of the terms on the outside, and that's going to give me 2x cubed plus 2x squared minus 24x. Then remember, you're drawing the line and changing the sign. So our x to the thirds cancel. Then I have negative 2x squared plus 24x, and you can bring the 0 down if you want to. Again, I'm comparing first term into first term, so I need to know what times x squared equals negative 2x squared. So that's going to be negative 2. And I don't even need to multiply back and find out what happens next. This is the only part that I need when I'm doing long division for slant asymptotes. So the slant asymptote is the line y equals 2x minus 2. Okay, so now we're going to look at the y-intercepts. So we're going to compare the constants on the top and the bottom. So there's not a constant on the top, so that's the same as 0 over negative 12, which will just be 0. So this y-intercept is at 0. Then on the right side of our squares over here, we're going to factor the top and bottom. Well, our top isn't going to factor. It's going to say 2x to the third power over x plus 4 times x minus 3. So in our top rectangle, we're looking at x-intercepts. So we're going to take whatever's on the top and set it equal to 0. So 2x cubed equals 0. So if I solve this, x has to equal 0. So my x-intercept is at 0. Our bottom square represents vertical asymptotes, so I'm going to take the factors in the denominator and set those equal to 0. So x plus 4 equals 0, x minus 3 equals 0, and solve. So x equals negative 4 and x equals 3. Okay, now that I have all of these pieces of information, I'm going to take these to the graph with me so that I can plot all of this, and then I'll find a few more points on my calculator as well. Okay, so here's my equation. I'll type that in the calculator. And remember to keep the top in parentheses and the bottom in parentheses. This is all the information that we just found. So the slant asymptote is at y equals 2x minus 2. Well, this is a line that crosses at negative 2 and has a slope of 2 over 1. So you're going to plot that line and draw it as a dotted line because it is an asymptote. Okay, then we have vertical asymptotes at 3 and negative 4. Okay, so again, I've got 6 little sections going on here in my graph. The only point that I have is the x and y intercept, which is 0. Okay, so I want to plug this equation in my calculator, and you can see from my view that I've zoomed way out on my calculator. So you can change your window to these same settings, or you can just zoom out a couple of times. The normal viewing window, you won't be able to see all of the parts of this graph. You can go to your table and find some more points to plot. So I think the furthest that I went out was about negative 10, maybe negative 9 looks like. So I picked a couple of points between negative 10 and negative 5. And I can see that it's kind of bound in this section here. And then I picked some points between negative 5 and positive 5 to find out what was happening between those vertical asymptotes. So I can see that it's decreasing in there. And then I picked some points after 3. And I can see that they're way up here at the top. So then when I connect the dots, it's going to look something like this. Okay, so you've got something happening in the bottom, it's increasing for a while, and then there's a turning point and it shoots down. In the middle, it's decreasing constantly where it crosses at 0, 0. And then in the top section, it's decreasing and then it shoots back up at that turning point. Again, you can type this in the calculator and verify, make sure that you plot a few points as well. On your homework, I'll be expecting to see that box with those 4 quadrants labeling the asymptotes and the x and y intercepts, and then I should be able to clearly look at your graph and see several points that you've plotted on there as well.